Welcome to Robotics on the Edge, November 2025 Breakthroughs. In this episode, recent advances in robotics research will be explored, spanning multi-sensor mapping, origami-inspired grippers, and beyond. 7 groundbreaking papers from November 1, 2025 are highlighted, with insights for engineers, students, and enthusiasts. The presentation includes real-world applications from city streets to ocean depths and outer space, and features a spotlight on the paper of the day by Lim and colleagues. Did you know that modern robots can now autonomously build detailed maps of unfamiliar cities, even when faced with unexpected events or sensor errors? Underwater drones are combining sonar and visual data to reveal hidden ruins beneath the waves, while origami-inspired robotic fingers are capable of grasping a variety of objects with remarkable dexterity. These machines are not only resilient when surprises occur, but they also keep learning and adapting over time. What was once science fiction is rapidly becoming reality, thanks to the latest research breakthroughs. Robotics research is fundamentally reshaping industries, transportation, and exploration. Today's robots are capable of perceiving, reasoning, and acting within complex, unpredictable environments. This episode spotlights cutting-edge discoveries recently published on the arXiv preprint server. The focus is on how robots are being developed to adapt, collaborate, and thrive outside the lab, bridging the gap between theoretical advances and real-world impact. Join the exploration of how these intelligent systems are moving from controlled settings to everyday life. The field of robotics can be envisioned as a growing city, where computer science, engineering, and even biology combine to create a dynamic landscape. Just as a city contains neighborhoods for vision, touch, movement, and learning, robotics research connects these domains with innovative bridges. Modern robots do more than repeat routines. They improvise and adapt, handling the unpredictable, messy nature of real-world environments. This integration is expanding the boundaries of what machines can achieve. The first major theme is multi-sensor fusion and heterogeneity. Robots are now capable of integrating data from cameras, LiDAR, sonar, and tactile sensors to construct a comprehensive understanding of their surroundings. Lim and colleagues have demonstrated methods for matching and aligning maps from different LiDAR sensors, even when data quality varies significantly. This process is comparable to a chef who relies on sight, smell, sound, and touch to perfect a dish. Such fusion is essential for robots operating in diverse fleets, as it enables more robust and reliable perception. The second theme centers on robustness to environmental changes and sensory noise. Robots must recover gracefully from unexpected disturbances or sensor errors, much like athletes adjusting to new track conditions. Deep learning techniques, such as those developed by Joe and colleagues, are enabling robots to adapt to unfamiliar and noisy inputs. When traditional approaches fail, advanced algorithms allow robots to find alternative paths, ensuring ongoing operation. This robustness is critical for deploying robots in dynamic real-world scenarios. The third theme focuses on adaptive manipulation and origami-inspired grippers. New robotic grippers, such as those designed by Nguyen and colleagues, employ flexible, folded structures reminiscent of origami. These devices can manipulate multiple objects of varying shapes and sizes using a single motor. This approach mirrors the skill of jugglers who adjust their grip on the fly. The result is efficient and versatile manipulation, allowing robots to handle everything from delicate grapes to rigid tools, facilitating broader application in daily environments. Several key innovations are shaping the current landscape of robotics, Lim and colleagues have achieved map alignment across heterogeneous sensors without relying on loop closure. Zhou and collaborators have enabled robots to recover from operational errors using visual feedback. Nguyen's group has developed grippos that can simultaneously juggle various objects through origami-inspired designs. Kim and associates have advanced sonar vision fusion, allowing underwater drones to map submerged ruins. Patel's team has introduced modular tools that significantly enhance the efficiency of lunar excavation missions. The featured paper of the day is Multi-Mapture by Lim and collaborators, which addresses a significant challenge in autonomous vehicle mapping, aligning spatial maps generated by different LiDAR sensors. Traditional simultaneous localization and mapping, or SLAM, depends on loop closure, a process that is not always feasible when hardware varies. Multi-Mapture bypasses this requirement by employing robust map-to-map registration techniques, aligning point clouds with algorithms tolerant to outliers. This results in faster, more reliable mapping for autonomous vehicle fleets. Outlier-robust map registration, as implemented in Multi-Mapture, is essential for aligning spatial data from multiple heterogeneous sensors. These methods are designed to ignore mismatched or noisy data points, focusing on areas of consensus for accurate alignment. The addition of pose graph optimization links discrete map segments into a cohesive global model. This capability is especially valuable for adapting to hardware upgrades and environmental changes. Lim and colleagues have released their implementation as open-source software, amplifying its impact across the robotics community. Multi-Mapture is motivated by the diversity and imperfection inherent in real-world autonomous vehicle fleets, where sensor calibration and hardware upgrades are frequent. The system is capable of handling these challenges, outperforming existing mapping methods in both speed and accuracy. Its ability to enable match sharing across evolving platforms represents a significant advancement in fleet autonomy. By open sourcing their code and insights, the international architect, Lim and colleagues have contributed to the advancement of open science and collaborative progress in robotics. Looking ahead, robotics can be metaphorically described as a river, drawing from tributaries such as artificial intelligence, biology, and materials science. The field is advancing toward machines that function as adaptable teammates rather than mere tools. Future scenarios include lunar excavators, underwater explorers, and domestic assistants. Despite remarkable progress, ongoing challenges persist, including robustness, seamless integration, and building trust in autonomous systems. Collaborative research and open scientific practices are catalyzing continued advancement. To recap, this episode reviewed significant breakthroughs in robotics, including sensor fusion, robust learning, and adaptive design. Lim and colleagues' Multi-Mapture exemplifies innovation in map registration for autonomous systems. Other highlighted advances include algorithms for error recovery and origami-inspired grippers for versatile manipulation. The field is progressing from controlled factory settings to wild, dynamic, real-world environments. Continued curiosity and creative ideas from the community will drive the next wave of breakthroughs. This presentation was synthesized using the GPT model from OpenAI, version GPT 4.1. Text-to-speech technology was also provided by OpenAI, with images sourced from Google Tools. A human expert reviewed the content to ensure clarity and technical accuracy. However, some minor oversights may remain. References to all major claims are provided. The combination of artificial intelligence and human expertise ensures a trustworthy and informative synthesis of the latest robotics research. In this podcast, the latest breakthroughs in computer science and AI are brought directly from arXiv preprint server. Topics range from neural networks to quantum computing, simplifying complex research so listeners can stay informed. Whether the audience includes developers, researchers, or technology enthusiasts, AI Frontiers delivers daily insights to keep everyone ahead of the curve. Thank you for listening. If this episode was informative, please subscribe for daily updates. More cutting-edge AI discoveries will be shared tomorrow. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.